Hey, so today I have an integral on the board, 6x dx over the square root of minus 3x squared minus 4. And what I'm going to do is I'm going to solve this two different ways. Both are going to be u substitutions. You may be able to guess what those are, but we're going to go through it. So my first method, I'm going to do a substitution. U equals minus 3x squared minus 4. And then I want to calculate what is du. We'll get the derivative of this, and it's going to be minus 6x dx. And you'll notice that's really close to the top. So what I'm going to do is I'm just going to make this a minus to make this a little easier, but we can't just do that. We need to bring a minus out front here. And then you'll notice all that is going to be u. So then rewriting this, we're going to have, well, minus on the outside of the integral, then we'll have du on top. And I don't know why that wrote that way, but whatever. And then we'll have a square root of u on the bottom. I'm just going to rewrite this as u to the minus 1/2 du, so we can just use the power rule. Minus u to the 1/2, 2. So just doing the power rule, we add 1, and then multiply the reciprocal, and we have minus 2u 1/2. And finally, that's just going to be minus 2, go back to our u, minus 3x squared minus 4 square root plus c. Okay, good. That was our first method. So now what we'll do, let me copy this and bring it down, and we'll do the second method. Okay, now for our second method, we're going to substitute, instead of just substituting the inside of the radical, we're going to substitute the whole radical, minus 3x squared minus 4. And what I can do to make this easier to differentiate, just because I don't like differentiating the radical, we can square both sides and get u squared equals minus 3x squared minus 4. Then we can take the derivative on both sides, and we'll have 2u du equals minus 6x dx. Again, this is similar to what we have in the numerator. We'll just add a negative. Very similar to what we did the first time. This isn't too different. And then we just need to substitute these values back in. So we'll rewrite this. We'll have, now instead of having just du on the top, we're going to have a 2u du. Important to remember that. So we'll write 2u du in the numerator. And then this is going to be our whole denominator. It's just u. But the nice thing in this method is that just cancels out, and we have a very easy integral of just 2 we're integrating. And so that's going to be minus 2u plus c, but let's substitute back in for the u, and we get minus 2, but u is just the radical, so we're going to have minus 2 minus 3x squared minus 4 plus c. That's it. And so you'll notice, okay, so you'll notice both of our answers are the same, minus 2 radical 3x squared minus 4. We got exactly the same answer in both cases. Which one do you think was easier? I might go with personally, I might go with the first one. The first one, the u substitution and the derivative is a little easier, but and the second one, the integral is easier, even though it's not a huge difference. So these are both pretty quick. I don't think there was a big difference, but just want to show that these can be done both ways. That problem came from one of my integral quizzes. I have an integration page on here. If you go to my website, I'll provide a link in the description. I have, I don't know what that is, 10 or 20. I can't count. We'll say 15. Actually, let's see how many it is. I have 15 integrals, 15 integral quizzes. So if you go to the integrals page, you'll see a bunch of different types. This one comes from integrals with roots. So you can check out this quiz, integrals with roots, and there's a few different kinds of problems. There's some with trig substitution, some like we just did with u substitution, some with some algebraic methods and simplification. So I'll provide a link to this quiz in the description, and I hope you check it out. Thanks.